cardinals in the room.
Thanks for all your suggestions and information on the last video. I learned a lot of things. Snow blowers, for instance. Snow blowers apparently use the same transmission as I'm trying to make here. I didn't know that because I've never met a snow blower. We live in a land with very little snow, and somehow we don't seem to need to blow that snow anywhere. The snow that we do get. Perhaps we're missing out on something important. What amazes me is how many of you do know about snow blowers. I mean, not just know that they exist, but have intimate knowledge of their internal machinations. Obviously, I just don't get out enough. But I do love the optimists amongst you who say things like, you can probably pick up a second-hand snowblower in your local scrapyard for very little money. Even if we did have a scrapyard, which we don't, I'd say there'd be more chance of finding a second-hand camel in it. I also learned that the friction drive in cars wasn't just from 100 years ago. There were much more modern ones too. And not just cars, sawmills use them, and some locomotives did too. And I learned that the friction discs themselves were sometimes made of hard rubber, as I'm trying, but also leather and fiberboard and layers of paper. Paper, eh? Who would have thought it? Seriously, I'm sorry if I didn't respond to your comment, but I did spend a day and a half reading them. This is why I make so little money on YouTube, usually around a tenner a day, which would be fine, but a video often takes a couple of days to edit. And then some get lots of comments, and I feel I have to read them all, everyone, and I do. Of course, the truth is the videos make no economic sense at all, but I make them anyway because I like making them and I learn so much from you lot. Anyway, enough babble. This is my Selector Arm. Maybe you could call it that. It's a way to push the friction wheel sideways across the face of the drive wheel. Now, many people told me I was doing this all wrong. Again, funny that, isn't it? I should have fixed the axle and just moved the wheel. Well, I was going to do it that way in the beginning, but once I'd seen what kind of forces were on it, I realized I'd need to give the wheel hefty supports on either side, bosses maybe, or sleeves, and they'd be likely to wear, especially if they're homemade from mild steel, because that friction wheel's trying to wobble sideways all the time. And of course that would wear the axle as well. And so I could have done it that way, using wide bosses to support it, but then I'd have to make more sideways space on either side, and the whole thing would just get bigger. This way, the wheel is supported completely by the bearings, and there's just no wobble or wear at all. So, thanks for that suggestion too, but seriously, try it yourself and you'll see what I mean. Either way, I need to push the wheel sideways in a controlled way. Other examples use nicely machined actuators that pivot and slide and push and pull the friction wheel. And they seemed a bit complicated to make, so my first plan was to close up the end of the axle and push on it with these ball casters. And I'm sure that would work, but they'd stick out quite a lot, so I decided I could do things more neatly. I looked at a threaded bar for a while. Ooh, look, there's a threaded bar. But decided the thread was too fine and it would take too long to move the selector bar that holds the sticks, that holds the bearings, that push the wheel that bears upon the bigger wheel. In the meantime, I remembered I had these little V bearings. When I figured out how to mount these in the right place, then they support the selector bar really quite nicely. It rolls along on them quite well. and with a bit of carefulness I was able to position the small bearings to tuck in well into the shell of the big bearings, enabling as much travel as possible. So now I could try it out, sliding it sideways by hand. And it was certainly promising. But how to control that movement? Someone suggested a rack and pinion from a car. Good suggestion, except the only one I have it's quite useful just where it is. So I thought about making my own rack and pinion using a chain and sprocket, and that would have worked too, I think, but it was a bit bulky. In the end, I used the same method that I used in the mott pedal cars. They have barrel steering, where a round barrel is rotated and that pulls wire cables attached to the steering arms. And I did the same thing, only I used a very small barrel, in fact a 12mm bolt, because it gave me the right sort of travel I wanted per turn of the barrel. Because the wider the barrel, the faster it would move the selector bar. The challenge in this setup is tightening the cable, because it only works when it's tight. There's no room for a bottle screw, so I threaded the cable through the hollow bar with the help of a willow stick and some string, and used a roofing hook to tension the cable from the other end, and that worked. I'm quite pleased with this mechanism. It does what I need it to do, and if the whole friction drive CVT thing works, then I shall make a nice wheel to replace the mole grips. Nothing wrong with the mole grips, but I think I can do a bit better. But I need to test it next. I don't want to go any further on this project, and I know it's going to work, or have a good chance of working. I mean, the whole thing's just an experiment. And if I had a tenner for everyone who says I should be making something with an electric motor, and then I could just go and buy one and do it that way. I just want to see if it works, okay? We all know petrol electric could work, and battery electric could work, and the hydraulic system could work, but what about this method? Could that work too? Sure, you want to know too, don't you? So I set up an experiment using some string. The plan was to pull the trolley along the tracks in the workshop using the friction drive. But instantly there was a problem. Big problem. The friction drive slipped. Wouldn't go round, which was disappointing. I mean, I know that sterling board isn't a great material for the drive wheel, so I shouldn't have been too surprised, but I thought it would work better than it did. The few millimeters on either side of the center was the worst, and it had better traction as I moved it further away, which makes sense, but still it would have been nice to see it bite a bit earlier. Now, if you listen to the engine, you can hear that it isn't really doing any extra work at all yet. So the problem is not the engine power, it's simply the transmission of that power. And if I push the friction wheel harder against the engine wheel, it would transfer much better for sure. But people have warned me, wise people, that that might not be good for the main bearings inside the engine, especially if they are plain bearings which are not designed for much sideways pressure. But I am reliably informed that the bearings in these engines are ball races, in fact, which can cope with lots of sideways pressure. Not as much as thrust bearings, mind, or cone bearings, but still enough for this experiment. If necessary, I could run a belt from the engine to another drive wheel and set that up for huge sideways pressure using thrust bearings everywhere. So there are always ways around the problem. But I was hoping not to have to buy more stuff for this. After all, so far I haven't spent anything at all. I'm just using parts from old projects. And of course, yes, I could just go and buy a gearbox, but they cost hundreds. So I was very sad for a while, and then I decided I would just in too high a gear, as it were. I was asking it to do too much, too quickly. So I reduced the size of the spindle that the string is wrapped around, and that made a big difference. From this, I should be able to work out the final gearing for the sprockets using using coffee and some cleverness and a calculator. Should be able to do that. In the meantime, I found another little pulley and looped the string around that and doubled it back to the starting point, thus reducing the gearing again. And that proved to be better again at starting from zero and speeding up to a good speed, and very little pressure was needed to keep the friction wheel turning. So that's very interesting, isn't it? Now I could do with an extra pair of hands for these experiments, but everyone's busy this weekend, so I'm on my own again. And I know there's very little weight on the trolley and it's on the level and all that, but still it's doing quite well under the circumstances, don't you think? So I shall keep going.